Have you ever played a game that just felt a little off? A bit stuttery, kind of slow? And then you play another one that feels incredibly smooth and just responsive? Well, the difference often isn't the graphics or the story, but something hidden deep, deep inside, its internal architecture. Today, we're going to pull back the curtain on how the brain of a game is built and how that design is what separates a frustrating experience from a high-performance hit. And this, right here, is the heart of the matter. In the super crowded world of gaming, especially on mobile, players have zero patience for technical hiccups. A game that stutters or lags is a game that gets deleted. Simple as that. The stakes for developers really couldn't be any higher, and it all starts with building a solid foundation from the get-go. All right, so let's dive into the biggest problem that so many games run into. It's this condition developers call the God object. Just imagine one single massive script trying to act as the game's brain, juggling every single task all at once. Yeah, it's not a genius brain. It's a hopelessly cluttered, super inefficient one. Now, this just lays it out so perfectly, right? On the left, you've got that God object brain, a total tangled mess where the code for player health is getting mixed up with the audio settings and the save files. I mean, trying to fix a bug in that thing, it's an absolute nightmare. But then on the right, you have the goal, a lightweight system. It's a clean, organized brain where a central hub just delegates tasks to specialists. So much cleaner, so much more efficient. So, how do we fix that cluttered brain? Well, the first step is basically surgery. We're going to split it up. We take that one giant script and we just break it down into smaller, specialized managers. This right here is the power of modularity. And this shows you exactly what that looks like. Instead of one script trying to do everything, you get an audio manager that only cares about sound, a UI manager that only handles menus and buttons, and a level manager that's just focused on loading scenes. And here's the real magic. Only the code you actually need for a specific task is active in memory. That's what gives you that immediate feeling of a lighter, faster game. Okay, so once the brain is organized, what's next? Well, now we have to teach it how to focus. A really smart system doesn't waste energy and resources on things that don't matter in the moment. It really is about working smarter, not harder. This is done using something called a finite state machine. Now just look at this racing game example. Think about it. When the game is in the menu state, why on earth would it need to calculate complex bike physics or what the enemy AI is doing? It doesn't. So we just turn all of that off. The brain is basically at rest. But the second the player hits start and the state switches to racing, all the menu logic gets put to sleep and the brain dedicates 100% of its resources to the race. This is how you stop the game from wasting precious CPU cycles. So it's not just what the brain thinks about, it's also how it listens. This is so important. The inefficient way is to just constantly check on things. As you can see on the left, this is like having a script that's just shouting, "Is the player dead yet? How about now? How about now?" 60 times a second. Can you imagine? It's completely exhausting for the CPU. The elegant solution is an event-driven model. Here, the system just listens quietly until it gets that one clear player-killed signal. The result? A much, much lower CPU load and a way smoother frame rate. All right, let's put the final piece of this architectural puzzle into place, mastering the game's memory. This is all about making sure the brain can recall and store information without causing those annoying little pauses or stutters that just totally ruin a player's immersion. One of the coolest techniques for this is called object pooling. Seriously. Think of it like an in-game recycling plant. In a game like Highway Bike Rider, you don't want to constantly create new cars and then destroy the old ones. That whole process creates garbage that the system has to clean up, and that's what causes those annoying micro-stutters. No, instead, when an obstacle passes you, it isn't destroyed, it's just deactivated, tossed into a recycling pool, and then bam, it gets moved up ahead to be used all over again. It's incredibly efficient. And when you're talking about mobile games, this whole memory thing connects directly to how people actually play. You know those micro moments? You're just playing for 30 seconds while waiting in line? You expect that game to load up and resume instantly. A well-architected system is designed for this. It's saving tiny bits of data in the background so there's no loading screen, no waiting. For you, the player, it just feels seamless. So after all these technical procedures, the modularity, the state machines, the event systems, the object pooling, what's the end result? What do we get? We get that elusive premium feel. You know what I'm talking about. It's the tangible, real-world result of having a healthy, well-architected brain. And this slide just sums it all up beautifully. Every single one of these architectural choices we've talked about translates directly into a better experience for the player. Modularity? That means fewer bugs and stable performance. Event-driven logic? That gets you those super smooth, consistent frame rates. Object pooling? Say goodbye to those distracting little stutters. And instant persistence? Well, that means the game is just ready whenever you are. This is how you take a game from feeling clunky to feeling absolutely premium. So, this leaves us with a final thought to chew on. The absolute best game architecture is completely invisible to the player. It works so perfectly that you forget it's even there. The goal isn't just to make a game that works, but one whose technical foundation is so solid that the only thing the player ever has to think about is having fun.